Okay, in the last video we left off with number 36, so I don't know if you can see that, but number 36 we've got a graph, right? And it says, at which point on the graph shown above are both the first and second derivatives of f of x negative? Okay, so I've already written it out here. The first derivative is negative where the slope of f of x is negative. And the second derivative is negative where f of x is concave down. So there's one spot on the graph where that's true, and that's spot C. All right, the slope is negative and it's in a concave down part of the graph. So that's one you can get really quickly. So the answer is C. On 37, it says the total area of the region bounded by the graphs of y equals sine 3x and y equals x is, okay, I went ahead and drew that out for you. Of course, y equals x is just a 45-degree line. And y equals sine 3x, and you could graph this on your calculator if you've forgotten what that looks like, but it's a sine curve. And so what we're talking about, bounded by those two, is y equals sine 3x is on top of y equals x, to the right of the y-axis, and to the left it's beneath it. But that is a symmetric graph. So you can just use your calculator solve to see where sine 3x is equal to x. Solve that and you'll get 0.7956. And then you can just double this area, since this will have the same area to the left side. So setting up that integral, the area is going to be 2 times 0 to 0.7956 of the top minus the bottom, sine 3x minus x dx. So put that in your calculator and you should get 0.523, which is D. Alright, number 38, we are going to skip. That one's just really not worth the effort. So let's move on ahead to 39. Okay, so 39, it's the region in the first quadrant enclosed by the graphs of y is equal to 2 natural log x and y equals 2 and x equals 1 is rotated about the x-axis. Which of the following integrals represents the volume of the solid? Okay, so let's draw that out. Okay, y is equal to 2 natural log of x is going to be something like that. Okay, and then you have the line x is equal to 1. Okay, that's going to be like right here. And y is equal to 2 will be right there. Okay, so we're going to revolve that around the x-axis. So the symmetric side is going to look like that. Okay, so this is going to be a washer problem. Okay, so our representative washer, we're going to be summing up those washers from one, and you have to see where they cross and where, so it's where y is, if you will put that in your calculator, let 2 equal 2 natural log x, solve that for x, and you'll see that x is equal to e. Okay, so, but that's all the options that they give you. It's always 1 to e in the answer, so you almost don't even have to worry about that. So you need to figure out what is the outer radius. So the outer radius is the distance from the x-axis to the top. Well, that's 2. And then the inner radius is going to be the function, okay, 2 natural log of x. So our volume, we're going to have a pi out front and go from 1 to e of the outer radius squared, 2 squared, minus 2 natural log of x, all squared, dx. Okay, and let's look at our options, and that one matches option E. All right, so you might have been able to figure that one out just by eyeballing it. Once you know that it's going to be the outer squared minus the inner squared and a pi out front, and the only one where that's the case is option E. So you might not have had to draw all that out and look through it. Okay, number 40, we have a table. And I really don't want to write that table out. If you'll just follow along with me. Okay, so we've got a table here. And it says the table above contains values of a continuous function f at several values of x. Estimate from 2 to 5 of f of x dx using the trapezoidal approximation. Well, the trapezoidal approximation is really easy. It's just a base, which for each of these, the base is going to be 1. From 2 to 3, from 3 to 4, from 4 to 5, the base is 1. And then the height is just the average height. So it'll be for 2, it's 0.21, for 3, 0.28. Take the average of those two numbers. Okay, so, and then you just sum up those three trapezoids. So if we estimate 2 to 5 of f of x dx, our first trapezoid, okay, the base is, so we're doing trapezoid from 2 to 3. Okay, so from 2 to 3 for x. The base is 1, and then the height is the average height, 0.21 plus 0.28 over 2. Alright, and then from 3 to 4, the base is 1, and then the height is 0.28 plus 0.36 over 2. And then from 4 to 5, the base is 1, and the height is 0.36 plus 0.44 over a deuce. Okay, I don't have the numbers for those individually, but if you add those three up, it'll be 0.965, and that corresponds to B. So trapezoids are easy, not much harder than rectangles. All right, number 41. Okay, we have this graph here. And it says that's the graph of the derivative, the graph of f prime of x. Which of the following could be the graph of f of x? Okay, well, one thing you'll notice is that that entire graph is above the x-axis. It's always positive. That means the slope is always positive. So for all of these options, the only one where the slope is always positive is C. Okay, so f prime of x is always positive, always above the x-axis, so we have to have C where the slope is always positive. It's the only option. So let me write something down for you on that. So f prime of x is always greater than 0. So the slope of f of x is always greater than 0. And the only graph where that could be the case is graph C. Okay, 42. All right, we got a related rates one. Okay, it says the radius of a sphere increases with a constant rate of 2 centimeters per minute. At the time when the volume of the sphere is 40 cubic centimeters, what is the rate of increase of volume in centimeters cubed per minute? Okay, so rate, what do we want? We want the rate of increase of volume, so that's dV dt. What do we know? Well, we know that the radius increases at a rate of 2 centimeters per minute. So dr dt is equal to a deuce. And we relate, and they gave us the sphere equation for the volume of a sphere, 4/3 pi r cubed. So we need to ddt that bad boy. So we'll have dv dt is equal to 3 times 4/3 is going to be 4 pi r squared, and then don't forget the dr dt. So we just got to figure out, okay, what is r? All right, so it says that when the volume of the sphere is 40, okay, so we can set that up. 40 is equal to 4/3 pi times r cubed. And you know, you can use your calculator to solve that, okay, and when you do that, you'll get a radius of about 2.12. So dv dt will be 4 times pi times 2.12 squared times 2, which is dr dt. All right, and when you plug that in, you'll get 113.124, and that is D. All right, pretty cool. You can do those. You guys are related rates experts. All right, 43 is different than what you've seen before, so I will show you how to do it. All right, it says, suppose G, excuse me for hitting the camera stand, sorry about that. Suppose G and H are continuous functions, and 3 to 7 of G of X dx is 6, 3 to 7 of H of X is 2, 3 to 4 of H of X is -4. Which of the following must be true? So the first one, says that H, the integral from 4 to 7 of H of X dx has to be 6. Okay, well it says that 3 to 7 of H of X dx is equal to 2. And it says from 3 to 4 of H of X dx is equal to -4. Okay, so does 4 to 7 have to be 6? Okay, or if 4 to 7, well, let me show you how to do it. Sorry about the hemming and hawing around. Okay, so you've got 3 to 4 of H of X dx plus 4 to 7 of H of X dx has to equal 3 to 7 of H of X dx. Okay, so we're just setting it up into different, we're splitting it up. 3 to 7 is 3 to 4 plus 4 to 7. Okay, it says 3 to 4 is -4. 4 to 7, we don't know. We'll call that x. And we know that 3 to 7 has to be 2. So x does have to be 6 in order for 3 to 7 to be 2. So number 1 is true. Pretty cool. If you know how to do it, it's really not that hard. All right, number 2. It says that from 3 to 7, G of X times H of X dx has to equal 12. Well, that is not necessarily true. We don't have any kind of identity for that. So that one is not true. You can't take one function's value times a whole different function's value and get the value of the two together. Those are not equivalent. Okay, so let's look at 3. 3, we have 3 to 7 of G of X plus 2 dx is equal to 14. So let's see if that's true. Okay, well, we could split this up into 3 to 7 of g of x dx plus 3 to 7 of 2 dx. And we know that 3 to 7 of g of x dx, according to the original problem, is 6. And that whole thing is supposed to be 14. So let's integrate this part. All right, that's going to be 2x from 3 to 7. So that's 14 minus 6, which is 8. Okay, so 6 plus 8 does indeed equal 14. So that guy is true. All right, so we have the first one and the third one are true, and that matches C. All right, 44.